Now there are just a couple of things that are remaining in assembly: motion link, tangent relationship, and motion study. In this lecture, we are going to understand about motion link. Now for this, we are having this worm gear assembly, where when we rotate the worm, the gear rotates accordingly. So we are going to create this assembly, but we are not going to make anything. We are going to use MacMaster car component, from where we can import these components directly into Fusion 360. So just click on Insert toolbar, go to MacMaster car component, and then you can find a list of varieties of components available, which you can directly import into Fusion 360 and you can start working on them directly. But for this particular lecture, we need to find gear. Now inside gear, we need worm gear. So let's select this metal worms and worm gears. Now here we will first import a worm with keyed bore. Let's select a 12 pitch worm and just click here and select 3D step and just press on download. And there you go. You have your component, ready-made component basically. You don't have to create anything. You can directly import it from MacMaster car component. Now next we require a gear corresponding to the worm only. So we will go to gear, metal worms and worm gears, and then we will select a gear. We have selected a 12 pitch worm, so we will again select here a 12 pitch gear. Let's select this one and download it, and just make sure this is 3D step. So our gear is also imported into Fusion 360. Just rename them. This one is worm and this one is gear. Now we have to make some slight adjustments. As you can see, they are overlapping. Just click on the worm, invoke the move command by pressing M in the keyboard, and just drag it upwards to some distance and rotate it by 90 degrees. Now we have to adjust it so that the teeth of the worm gets in between the teeth of the gear. For this, again invoke the move command. In move object, you have to select component, because this is a component, this is not a body. Select any point, anywhere, and then drag it downwards. Little bit right, I guess. Now even with precise hands, you cannot be sure that there is some interference between the two components. So for this, what we will do, we will go to inspect, select on interference, capture the position, select this, and let's compute. As you can see, there are some interference over here. So we have to adjust them. So this is like a trial and error method. You have to adjust it using the move command obviously, and then you have to again recheck it until and unless you are getting the interference as a 0, you cannot move forward. Just click on OK for now, and let's move it by, let's say 0.2. Let's again check it. Select both the components and compute. You can see still interference is there. So we are going to repeat the process until we are getting zero interference. So we are going to fast forward this particular section. As soon as you get this no interference detected notification, you are good to go. Just click on OK and cancel this one. That means there is no interference between these two. Now we are going to learn a new concept. Let's create a new component. Let's name it worm axis. Click on OK. And now for this new component, we are not going to create any 3D model. We are just going to create from the construct toolbar a axis through cylinder, cone or torus. And then we will select this particular profile of worm and then click on OK. So this particular component will only have this axis. So this component can be regarded as a pseudo component because it is not having any geometry, any sketches, any 3D model, but it is still a component. And we can use this component, this axis basically, which is converted into component for providing joints. Now let's provide joint between these two. So we are going to use again the as-built joint just like we have used in the previous assembly. Press Shift plus J in the keyboard. Select this component and select this pseudo component which is just an axis. The joint type would be revolute and snap to this point. And you can see a rotation of worm is seen. Just click on OK. Let's do the same thing for this one also. Just create a new component. Let's name it gear axis. And then again create an axis through cylinder, cone or torus and select this profile. Click on OK. So this is yet again a pseudo component, a false component. Again invoke the head assembly. Invoke the as-built joint, select the gear and select this pseudo component, this axis, and snap to, let's say, this point. And this one is also revolute. Click on OK. Now what we need a relative motion between these two joints. So that when we rotate, okay, this is moving freely, we need to ground something. So again, we can use these pseudo components to ground them. Let's ground this. So this cannot move, this can only rotate. Is this one moving? Yes, this one is also moving. Revert the position and ground this pseudo component also. So both the pseudo components that we have created, the axis that we have created as components are grounded. Now what we need, as soon as we rotate the worm, this gear below should also rotate accordingly. So we need to provide some relationship between this revolute joint and this revolute joint. And that relationship is what we call motion link. Just click on motion link here. Select this joint and select this joint. And as you can see, we can have a relative motion. And just click on OK. So this was your motion links. Now coming back to these pseudo components, we can hide them. So they are like they were never here. But they did the work, they did the job of providing the motion link.